Alright, today I'm going to talk about IO planning manually from packages. Um, and later on, we're going to generate this XDC file from these packages. So, in this exercise, uh, this is Alveo U55C board. I have a video uploaded earlier. This is very simple design and gate right here. I'm just trying to show how to manually define the IOs. So I already synthesized and implement how to run them because it takes quite a lot of time to compile them. Um, if you are working on understanding some stuff, I would rather like to understand let's say for example the delay and wait a second, yeah, not delays. Oh, I think it's out of date because of so in order to check all these things and the devices where it's placed and then how they're routed, understanding the architecture of the FPGAs itself, it's better to work on the smaller FPGA. But again, it should be uh, if you have a license, then that's fine. Otherwise, it's better to use those devices which is under standard edition. Again, I have another video on the FPGA series, so you can choose any one of these: Kintex, RTX, or whatever, Spartan. Yeah. So okay, so I've already compiled them earlier. So what I'm going to do is I'm going to go to IO planning and go to packages. Then I'm going to click right here, and so this is the bank 67 as you can see here, and these are a list of available pins, physical pins I would say. So if you scroll down here, you can like delete them, prohibit, unplace them, or you can E, B, and this will be output C. You can use them, and you can select the IO standard. This LVCMOS 1.8 volt, and it's in 67 bank. And then you can go to IO ports and then select the pin from here. You can select from here as well, and then I choose to fix them, and then again here the same thing. You can select the drive strength. Let's say for example for now I'm going to change to 6 for example. Sleeve type, make it medium. Yep. Okay, alright. Termination none. Okay, let this be none. Let me change this to keeper for a while, just for the sake of testing. Right, so we are done. Keeper, okay, it's reflected over here as well. Let me save this. I saved a quite few of time earlier, so as you can see it has generated various folders. Constraint 1 through 6 7 8 have generated 8 times, and this can be found in your work directory, which is right here. Test sources, yeah, these are the ones that I generated. I'm going to generate one more in this video, which will be constraints 9. Okay, if I override it will be an error, so I would rather generate if constraint is constraint 9. So yeah, just got generated. All right, so this is the main XDC file generated from here. Let me separate them. Okay, just I'm just organizing them. Yeah, and this, so we set some properties for output, that is C. Um, so that is what's coming up. As you can see, the drive strength is 6 right here. Um, then medium, slew, keeper, pull up. Yeah, so you can, from here you can modify as per your wishes, your wish. In fact, I would rather always download the XDC file from the vendor, for example. Yeah, this is helpful when you are developing your own board. If you already have, if you're buying a development board, like let's say for example Alveo, then in that case, it makes sense to download the XDC file. Um, and for example, the XDC file for this Alveo can be found uh, right here. Where is it? Where is it? Where is it? Yep, XDC folder. Yeah, so there is the one. Yeah, you can just straight away use them, comment whatever unnecessary and comment uncomment the necessary. Yeah, so that's it. Like as you can see, set property, packet spin, get port, blah blah blah. um, One thing that I would like to mention is, for example, the one that we have already. I would generally do this. Let me bring up a small piece of, where is it? Where did I kept that? Hmm. Is it here? Ah, yeah, it is here. All right, let me copy this. Paste it right here. So, for example, like I can replace C. Okay, let me work on C right here. So it's IO standard LVC18. I'm gonna delete this. Right. So IO standard LVC was here. Slew as medium. Drive as 6 right here, and then I can add this bootstrap keeper right here. And what else? Packet spin. I can put it right here. Yeah, I'm going to pull out what's the difference between packet spin. Uh, so yeah, so you can here you can combine these lines and anything related to C. I would say this line number 5 and line number 1 in a single line right here. Straightforward, right? Okay, for now let me just comment it out. So what's the difference between lock, there was a lock, and packet spin? uh, so if I remember correctly, packet spin is mainly for the physical pin. And okay, I already searched it. Yep, cool. Is it good enough? Yeah, I think so. Yeah, packet spin, as you can see, it's for physical pin, right? So physical pin and the signal, whatever signal you can assign, uh, which we are doing right here in this example. Yeah, packet spin. And for the lock, you can use any cells, components, or even the pin itself. So yeah, um, if you want to, if you have a logic, and let's say for example in this case AND gate, even if you want to specifically glue it into a specific location, CLB, then yeah, you can use this. And yeah, so that's it. That's that. And what else? So okay, yeah, another thing that I would like to mention about is about XDC. Before it used to call UFC, the constraints file were called UFC. So for that, the most important document is XDC is Vivado. Uh, the user guide, okay, right here, UZ903. I'm going to put this in the link in the description. So for example, the packet pin comes under what? Physical pin, physical constraint, and most probably on the IO constraint. Let's have a look. SLIO, the one that we were looking at, every drive, the descriptions we can find right here. IO standards, which we were just using, right? Drive, SLIO, pull up, blah blah. And how about what about the package? Sorry, yeah, package pin. For that, let me just search instead of scrolling up and down. Okay, yeah, it's under physical constraints. Oh, I it was next. Okay, yeah, Asian and blah blah. So this is a very useful document. So it's using 903, and that's very important to keep the latest version. You can see the 2024. I'm using 2024.1 Vivado. Yeah, so if you want to learn, if you want to, okay, so for example, how to constrain the input delay, it's all here. Add delay, create clocks, add input delay, blah blah. Then output delay, the same thing, and clock domain crossing constraints can be seen right here. Cool. And then what else? Timing exceptions like false path, multi-cycle path, very important stuff. Um, then what else? Okay, valid commands, XDC. So yeah, I'm not familiar with them, but yeah, even I have to read in details this particular document. Yeah, so there are lots of documents. I will make another video choosing a specific family and understanding each and everything, starting from IO, starting from how the user guide are arranged and how to organize them. You know, it's a lot of document. It has to be well organized and well linked, otherwise it's gonna be a messy. Uh, so after this, I can directly generate the Bitstream. It should be the active. Okay, so right now this was the latest one. It's active, and I can directly generate the Bitstream. Mm, yeah, and that's all for today regarding the I also I'm gonna make a detailed video as well. This is just for you have a development board and you want to like quickly do something with your switch, your LEDs. Um, yeah, and um, Yeah, and moreover, for Alveo, we don't have any LEDs or switches. So if you buy anything from, Viva, sorry, Disneyland, they have a clear documentation. Let's say basis tree, or I would say Z board. Uh, so they have a very clear documentation. You can download the XDC file as well, or you will get to know from the block diagram of the document, and you can see where the LEDs are connected, and pins are the switches are connected. Mm, where is the document? Um, where was that? I forgot. What's included support is it? Yeah, reference manual. Download the user guide. For example, here we know that it's 33, 100 megahertz. What is this PS? I'm not sure. Crystal oscillator on board, and from here, I think they should give the XDC file as well, right? Yeah, if you Google it, you'll just find it. Yeah. So from here, you'll get to know like the location of the switch and the pin number. Yeah, here it's written. So for example, the LED, you can just, if you're using this particular board, you can just copy this, or and paste it right. Where's that? Right here. Yeah. So sorry for the noise. Yeah, so that's how you can do it. So the best would be downloading the XDC file if you are using a development board of that particular board, and reading its documentation where it goes where, and then you just just quick test setup. You can paste the LEDs as an output, then choose switches as an input, and you can quickly test the logic for a first example when you buy this development board for the first time. Yep, that's all.